Your phone's out, go ahead and you don't have to shut down as we get your phone and constantly press back on. But get ready for notes. You can see what's on the board here. I want you to go back to your reading guide and see where that is in your reading guide. Okay, so come back up to the front. We're going to start notes together. Earphones out, close your computer so that I know you're with me, and we're good to go. So either close or have a close your computers and everybody come back up to the front. Yeah. Finish that first. Alright, so from your reading guide and your interactive, what you're probably realizing now is that now you're starting to learn a new language. I know you didn't start for a world language class, but you are learning how to speak chemistry in. Okay, you're learning how to speak chemistry, write chemistry, speak to me in symbols so that I know what you're talking about, things like that. So we're going to briefly talk about like what each pieces of the language are. So like what's a chemical symbol, what's a chemical formula, what's a chemical name. And then I'm going to remind you of all the things you already know about ionic and covalent. And then we're going to dig in and actually do this. We're going to name them, we're going to write the formula. So who watched the Ed Puzzle video with the crisscross charges? Okay, that is a fact of life for us from here on out. We have to crisscross charges if there are charges. What kind of things have charges? What kind of compounds? Ionic are the only ones with charges, so we only apply that in very special scenarios. And then on your reading guide, or maybe you guys watched the other video, on your reading guide you guys saw stuff with prefixes, right? Like di, tetra, octa, deca, there are all these prefixes we have utilized. So that's what we're going to kind of pull together here, okay? So the first two things that we should know is that we have to follow the law. We're not rule breakers. We follow all the rules we're given. These are two laws that you've had on number 16, right? So just basically this means one scientist said, okay, they're going to have, whenever you put chemical or put atoms together, they're going to be in defined proportions. And another one elaborated, this one you know, Dalton, he elaborated and said, no, they don't have to be in a definite proportion. There are many, many, many proportions. There are multiple proportions we can put atoms in arrangement with each other. So basically, if I have H and O, what are all the ways that you know we can put H and O together to make a compound? Two very familiar things. H2O, okay, and H2O2. So this law says, nope, you can only have an arrangement where you have H with two, or water with two H's and one O, but that's no longer true because we know that there's as such that we can make other arrangements and they will make stable compounds that exist in everyday life. And that's what Dalton helped us to see is that we could have multiple proportions available, hence hydrogen peroxide. That's it. Stuck ratio, flexible ratio. I'm moving on because this was just a term on your reading guide. Okay, so like I said, we have symbols, we have chemical formulas, and then we'll have chemical names and equations eventually. So when we have symbols, we just literally, where do we get these symbols from? Periodic table of elements, right? So what's that first symbol for? Sodium, and this one's for chlorine. So we have to be familiar enough with our symbols so that when I give you a symbol like W, tungsten, right? So that one doesn't really make sense, but some of them are coming from olden times when we called things differently, or we named things after people's first names or last names and they just weren't the symbol that was available. So in chemistry we have symbols for elements, but usually we'll just call this an atom of sodium or an atom of chlorine. So when you say atom, I think singular circular thing. So that's what those are. But when you start to put atoms together, what are you building? Compounds, right? You're building bigger things or molecules. So there are two names for compounds. Compound is just kind of like the general word. The two names that kind of describe the compound is molecule and formula unit. We abbreviate this FU. Okay? So molecule Where have we used that before? In describing what kind of compound? Covalent, right? So we always use the word molecule, like molecular geometry, molecular shape, intermolecular force. We've been saying that word a whole lot as of recent. So we're going to use that word molecule to describe anything that is bound together in a covalent fashion. What generally is that going to be consisting of? What kind of atoms? Nonmetals all the way, right? So nonmetal would be how we would be describing, if two nonmetals came together, we would describe them as a molecule. So give me an example other than carbon dioxide of a molecule. Anybody? You breathe it. Oxygen, O2, okay. You drink it. Water. Those are going to be that's a molecule of O2, that's a molecule of H2O, okay? Now if you have the opposite, something that's ionically bound, we haven't actually said this one out loud because it's kind of a weirdo. A formula unit of an ionic compound. Okay, so it's not doesn't just come off the tongue like molecule does, but we do call anything that's ionically bound a formula unit. An example for this one would be NaCl. What is it consisting of? Well, I know sodium chlorine. Sorry, what's the types of atoms? Say again. Sodium is a metal. Okay, sorry, I couldn't hear you. Metal and non-metal. So that's how we know it's ionic. Okay, so eventually we're going to be like super awesome at building our own formulas and compounds, and then we're going to let them react, and we'll build via reactions new compounds. So eventually we'll get here. Thumbs up when I can move on. Symbols, compounds, eventually those compounds react. Okay. So in this scenario, SO3, you should be able to tell me a whole lot about this compound. First off, we know the types of elements that are involved. So what kind of elements are involved here? Okay, sulfur and oxygen. They're both what? Non-metals, right? Okay, so that's your key thought. They're both non-metals. So what kind of compound am I dealing with? So I'm dealing with a covalently bound molecule, right? So I can already tell just by looking at the symbols that are involved a lot about this. So I start thinking, oh, what are all the properties of covalent? Name them off. Boiling point is low. Solubility is crap, right? It's not going to dissolve. Is it volatile? Volatile means it vaporizes easily. Yes. Does it conduct electricity? No. So like just now that we know it's covalent, we see the two types of atoms involved. We know so many properties about it. So that's the beauty of like having a little bit of insight into what we're looking at. Now, when you look at the subscripts, what does sub mean? Below, like a submarine goes below the ocean or the water. So sub means this number here, 3. What's the subscript on the S here? It's a 1. We don't write the 1 because it looks stupid. That's really why we don't write it. So if there's no number, understand it does mean there's still one of those atoms. And then we know the compound type, therefore we know its properties. Okay? So is this a molecule or an ion or a formula unit? This one? It's a molecule because it's what? How is it bound? Covalently. I'm moving on. Okay, so this is kind of some of it's review, some of it's new stuff. I'm not going to do this one yet. Well, no, let's do this. Can you guys just tell me if it's ionic or covalent? I immediately know it's ionic because what? Metal, not metal. Covalent because... Say again? 2 nonmetals. Next. Ionic because... Metal, non-metal. Next. Ionic. Next. Covalent. Next. And so from those, you know all the properties that stem from them. You are the master of the properties now. Okay. So, nope. Moving on from there. I had some things that were redundant. Not sure I'm actually touching this. Oh, okay. So, this is stuff you've seen before. Like if you've ever looked in the back of a package, if you've ever like tried to look and see what's in there, maybe food that they're eating or drink they're drinking. You guys just take their word for it. It's all healthy and good. You just trust the system. Okay, don't always trust the system. I thought this was interesting. The UK has a very strict FDA, so they manage what's going into their foods a lot more than the US does. they do, remember like GMOs back in biology? Yeah. They're like, this contains 0.001% GMO. They'll make that very loud and proud. Where in the U.S., we're just like, don't tell them unless it's non-GMO. This doesn't contain any GMOs. So that was kind of an ethical debate of like what the U.S. should do versus the European Union. But really, GMOs are not harmful, so it doesn't matter how they're labeled anyhow. But there are two different branches here. But some things that you should notice are that we know what some of these are. Like, I know what sugar is and corn syrup and baking soda, but let's say dicalcium phosphate, sodium steroid lactylate, xanthan gum. You don't know what some of these things are. We are going to learn what these chemicals are in some way. In some of these, we may not understand what the stabilizer is. They don't really tell us. Or carboxymethyl cellulose. You know what cellulose is. Yeah. But some of these things will become apparent to us because we'll learn their chemical symbols and what they mean. Others, you're just going to have to look up on your own. It's organic chemistry and it's about your pay grade you'll take it in college. But look at all these. What do you recognize? Okay, give me some elements. Give me some chemical aspects. Monocalcium phosphate. Okay, so phosphate is going to be one of those polyatomic ions we learned. Calcium carbonate. Sulfate. Yeah, not many. Okay, good job, guys. So basically, you'll start to see that you can look in the back of the package eventually, and you'll know what these things are saying. Okay, so we're going to start with ionic. So we write an ionic formula. What two things are coming together to make the ionic compound? Before you start writing, what two things come together to make an ionic compound? Either a metal and a nonmetal. That is one variety. That's one way to say it. Or, I'm just going to say two ions. Those are the only two ways you can make an ionic compound. Take a metal and a nonmetal, put them together, they make ions naturally. Or if I give you two separate ions, and one's a cation and one's an anion, they will come together to make an ionic compound. So what you must do first when you're writing out the formula is you have to get the symbol, and these are two places you would find the symbol. PTOE, what's that mean? Periodic table of elements. And from that symbol, look and see where it is in the periodic table and find the charge. How do I find the charges? Valence electron. So my pointer's at home, so I'm going to just point at the periodic table. So go in order. If these things form charges, what does group 1 form? +1, group 2. +2, skip over transition, group 3. +3, group 4. Plus or minus 4, right? It kind of depends on the system. Group 5. -3, group 6. Minus what? 2, okay, and then group 7. -1, so it goes 1, 2, 3, 3, 2, 1, right? The 4s are kind of the weirdos. And then noble gases don't do anything. Okay, so the other way you could find information is from a polyatomic ion sheet. So I'm going to give that to you now. This is the bane of your existence for the next week. Okay, my students end up finding different ways to memorize them through mnemonic devices, through YouTube videos, through flashcards, whatever. But there are like 300 to 500 polyatomic ions, and I am giving you a list of like 15 or 20. So I'm going to go ahead and let you use this all later in class, and eventually we'll get to the point where we are not going to use it. Courtney, tell us about the polyatomic ions. How long did it take you to memorize them?
Probably like a week or two. Yeah.
So the struggle was real for a little while. Susie, how long did it take you to memorize the polys? Like 30 minutes. I'm right. See, optimistic here. I don't know if I believe that. All thank you. I don't believe it. Okay. Everybody got one? Oh, who's out? Elizabeth and there's somebody else. Oh, sorry. Okay, so what you'll notice is that every single thing, sorry, we're scooching around here. Every single thing here is what kind of ion on all these? What kind of ion is that? These are all anions, but look how big they are. They've got all kinds of elements in them. So we call them polyatomic, because what does the word poly mean? Many, so polyatomic means many atoms, right? It's like 2 chromiums and 7 oxygens, 1 manganese and 4 oxygens, 1 nitrogen and 2 oxygens, 2 carbons and 4 oxygens. So they all have their own charge, they all have their own symbols. You with me, Paul? Okay? They all have their own symbols, and so they all also have their own names. So if I say nitrate, what's the formula for nitrate? NO3 what? NO3 what? 1 minus, right? Remember that if there's not a number there, it's a 1. What's the formula for sulfate? SO4 2 minus. What's the formula for acetate? Acetate. C2H3O2 1 minus, right? So that's going to start to be something that you, like, we can go get, like, acetate tattoos together. I don't care. You guys got to memorize these things. I'll tell you my way to remember this one. There's not many with 3 letters or 3 symbols. So acetate, 3 syllables, C2H3O2. Okay? Yep, that's the only thing I got for you right now. All right, moving back here. All right, so now we know where we can find these ions, right? PTOE are on the sheet. Once we get the ions with their charges, we literally crisscross their charges to make the superscript charges become subscripts. So we switch them, yes. So for sodium, it has a 1 plus charge. Chlorine has a 1 minus charge. When I crisscross, the 1 from sodium comes down to the outside of chlorine, and the 1 from chlorine comes to the down on the inside of sodium. These are now subscripts, whereas these previously were charges in a superscript. I should put so again, superscript position. So I'm taking the superscripts and making them subscripts. But I'm not taking the plus and the minus because it doesn't make any sense to do that. So now I've changed the formula to Na1, Cl1. Do I write the ones?
No.
No, why? They look stupid. Okay, moving on. Calcium 2 plus, chlorine 1 minus. Where am I getting these charges from?
The
Periodic table, and I crisscross them. The 2 comes down, the 1 comes down. So we form Ca what?
Cl2.
Well, I'm just going to get the numbers for a second, okay? Ca what? 1, Cl2, and this ends up being how we write it. Okay, let me give you another one. Potassium oxide. Potassium oxide. Think about what those 2 symbols are. Well, write these examples in your paper. I'm just going to give you a couple orally, okay? Potassium oxide. I'm going to give you 2 more up here, okay? Potassium oxide and aluminum sulfide. All right, so Camilla, walk me through the whole process for potassium oxide. Give me the baby steps.
Okay, so potassium has 1.
What's the symbol for potassium? Hold up, get me started.
Okay.
K. And it has a,
Charge of +1.
because it's in group 1, right? Okay. And then the other one is what?
Oxygen.
O, right?
Yes. And it has a charge of minus.
Because it's in group
6.
Group 6. Okay, so what are you doing with these charges? Okay, and what does that mean in the end? K2O is potassium oxide. Okay, Hannah, can you do aluminum sulfide?
Yeah, aluminum Al.
Okay, so aluminum symbol is Al. Okay,
And it has a charge of 3 plus.
because it's in group
Yeah.
group
Or, yeah.
group 3, so it's got a 3 plus. Okay, sulfide.
The S, and then 2 minus because it's a group 6.
And
And then you crisscross it. So it would be Al2S3.
very good. And that's it, my friends. That is the, now this is called type 1 ionic. It's a binary system. What's binary refer to? Two, so it's in one element and another element. Notice I haven't used any polyatomic ions yet. Okay, so one element and another element creates a system like this. Now, if I have a polyatomic ion, that means it's going to be just a bigger ion. I still do exactly the same thing. I still crisscross charges. But my one caveat is that you have got to put parentheses around the poly. Parentheses around the poly. Parentheses around the poly. And that's going to save your butt on many occasions. Because if you don't put parentheses around the polyatomic ion, you end up telling me an inappropriate number that you need to make an electrically neutral compound. Electrically neutral means what again? Zero charge overall, right? So as you can see in this example, magnesium, from my example, I'm telling you it has a charge of what? 2+. But acetate has a charge of 1-. Well, how many of each of these do I need to make a neutral compound? Why do I need 2 acetates? Well, it's related to octet because of this transfer of electrons.
Yes, because magnesium would have one left over if they were going on.
Right, and you can see it simply by, if I have 2+ over here and only 1- over here, that 2+ and a 1- makes a total of what? Well, 1+. It's not electrically neutral. So instead, I want to have magnesium 2+ and then 2 acetates, because then 2 acetates together will be 2+ plus -1, and -1 will overall give me an electrically neutral compound of 0 charge. So instead of writing out acetate twice like that, when we do the crisscross rule, it automatically works out for us. So we have magnesium 2+, and then acetate C2H3O2, parentheses around it. The charge hangs on the outside. Okay, if you put the charge on the outside, you won't mess up. So now what are we going to do with these charges? Say again? Cross them, so the 2 comes out here to the outside of the parentheses of the O2 back out here, and this 1 comes to the back side of magnesium. So we end up writing an Mg with a 1, but we're not really going to write the 1 because it looks stupid. So put your parentheses, C2H3O2 parentheses, what? 2. So that 2 right there is telling me I need 2 acetates to balance out the charge of magnesium. Okay, so that's why the crisscross rule will always work. But if you don't put a parentheses, what does it look like on the end down here? 22 oxygens, ain't no way, right? That's not going to work out for us well. So that's why we have to put the parentheses to indicate the correct information. Okay, so I'm going to leave this here for a second. Tell me what else you need from me. So far the rule is what? Get the symbols, write the charges, crisscross. Get the symbols, write the charges, crisscross. Okay. Parentheses if it's a poly. Parentheses if it's a poly. All right, give me a thumbs up here. Okay. So we're going to do this part tomorrow. So before, I'm not going to go into too much more depth right now. I want you guys to, one, look at these. If you're a flashcard person, I'm going to give you some index cards. If you're actually memorized by writing this down 2 or 3 times, I'm good. Okay? Or maybe just quiz each other for a little bit. Okay? Take a couple minutes and do that. If you guys start memorizing these.
No, that's pretty good. You got A's from Hydra.
Alright, put your laptops up, please. Put your laptops up.
Minus 2.